I want to look at just a couple last things dealing with polynomials here. The first one asks us in example 7, explain why a polynomial function of odd degree has at least one real zero. Okay. So based on what we've talked about so far today, if we have a polynomial of odd degree, think about what the picture would look like if we were to graph an odd degreed polynomial. Okay, why are we guaranteed that it has at least one real zero? Think of a way we could say that besides what they wrote. What do we know about the end behavior? We have an odd degreed polynomial, the end behavior going right. Let's just say we have a leading coefficient that's positive. Going right would be infinity. Going left we'd be at what? Negative infinity. So doesn't the intermediate value theorem guarantee then that somewhere between infinity and negative infinity there's going to be a specific number we're interested in, which is what? 0. True? We can't go from positive to negative or negative to positive without crossing 0. Okay? And if it's a polynomial, okay, it's continuous. Again, remember this all hinges on continuity here, but when we have a polynomial function, polynomials are always continuous. Okay? So that theorem would guarantee that we'd have at least one real zero. Why is there no guarantee for even powered polynomials? Both end behaviors are going to be either positive infinity or negative infinity, aren't they? So think about that. If I had a parabola or a fourth degree function, etc., if the whole thing, if the vertex parts of it or whatever, the lowest it goes is above the x-axis, would it have any zeros? So with an even powered function, there's no guarantee that we would have any zeros. Okay. All right. I want to look at this quartic function also that they have here. Sometimes when we graph functions that have higher degrees, we may or may not see all the behavior. Okay, if we were to put that into our calculator right now, we do x to the 4 plus 0.1 x cubed, and it's minus 6.5 x squared plus 7.9 x minus 2.4. So if I do just a standard window for that, I'm going to go zoom 6. Then we can see a little bit of this. We can see that it comes down, goes back up. The end behavior appears to be right for what we know about quartic functions, right? Okay. We could, if we wanted to, we could zoom out a little bit here, change my window down to, let's say, negative 30, and then hopefully we can see the extreme value that we couldn't see in the first window. Okay. Okay. So we can see that pretty good. What we can't see very good by looking at this wide out zoom is we can't see what's going on right here, can we? Yeah, we can't see that very well. So let's go ahead and zoom in on that spot. I'm going to hit my zoom in button. I'm going to move it up there by that part. See if we can get a closer look at what's going on there. So even with that, we really can't see real well what's going on there. It looks like watching it work that it went up and then maybe it goes back down and then back up again, which again shouldn't be too surprising with a quartic function, but it doesn't go down very far, does it? And so if we zoom in one more time, maybe we can get an even closer look at it. Okay, so there it's going up. So it does in fact go down and then back up. So if you zoom in on that, you can see actually what's happening on there a little bit better. If you're out in that wide zoom, okay, you may not be able to see that behavior. True? So one thing you want to be careful with when we're dealing with a graphing calculator, we're graphing polynomials, is that we know what to expect because it's a quartic function. If we know that, then we kind of know what to look for a little bit, don't we? Okay. If we didn't know much about quartic functions, then we might not even look at that behavior and see that extra maximum and minimum. Okay. All right. And one more I wanted to look at real quick, just to take a look at this exploration 2 that you have here on page 208. Just to point out, in your calculator, we've done quite a few different regressions so far. Just to illustrate, you do have in your calculator, if you do stat calculate, you do have a cubic regression. So if the points look like they're cubic, you can do a cubic regression and get a cubic function for them. Okay, and you also have quartic regression as well. Okay, now your calculator does not do anything higher than that. It doesn't do quintic or any 6th degree or 7th degree or anything like that. Okay, but you do have cubic and quartic that you can use. So if you have points that behave like a quartic function, okay, you can use quartic regression. All right, questions so far?